welcome. I wanted to take my prerogative as chair of Josh's committee to welcome everybody to this defense. It's great to see so many people actually here, given the time of the semester, when I know everybody's feeling slightly overwhelmed with things that they're finishing for their courses. And so I wanted to congratulate Joshua on getting to the defense portion of his studies, and I wanted to thank the committee for doing a tremendous job on guiding Joshua through this process. I couldn't have done it without them, and I mean that quite explicitly. And so I wanted to welcome Dan and from Environmental Science and Policy, and Solon to this defense as well. And so the way we'll proceed is that Joshua will present his study on ecological correlates of armed conflict, which I have to say is one of the most interesting dissertations I have read since coming to ICAR. And then we'll have the committee ask some questions, and then we'll open it up to everybody for comments, questions, and so forth.
I'm Joshua Fisher, and today I'm discussing my dissertation. It's titled The Ecological Correlates of Armed Conflict, a Geospatial and Spatial Statistical Approach to Conflict Modeling. My presentation consists of several parts. First, I'll outline my research question. Then I'll provide a brief summary of the theoretical background. Then I'll present the research design for my empirical work. And finally, I'll end by discussing some findings, some implications, and the conclusions of my research. So the question I explore is, do ecological and environmental conditions affect where conflict occurs in the world? When I think of conflict, two types of questions come to mind. Why does violent conflict occur? And where and under what conditions is violent conflict manifest? The first question explores the social drivers of conflict. Conflict is fundamentally a social phenomenon and is thus driven by social processes. The second question, however, explores more than just social processes. At the local level, environmental, geographic, and topological factors all impact social systems. These factors are not direct drivers of conflict, but rather they influence social dynamics and affect conflict likelihood. Traditional social science explores the first question very well. Very few studies, however, explore the second. We know that conflict occurs in specific locations. Rarely is it distributed evenly across a state or a province. And conflict manifests itself in what I refer to as islands of violence. So what factors determine which locations experience violence? Distinct locations on the Earth have unique social profiles that affect conflict likelihood. They also have unique environmental and ecological profiles. Environmental profiles include things like land cover, climate change, climate conditions, habitat. Ecological profiles, however, are defined by the interaction of societies to these environmental conditions. These include things like land use, like livelihood strategies, culture, religion, anything that ties humans to the environment. Historically, social and natural systems have been viewed as discrete, mutually influencing perhaps, but discrete, and thus studied discretely. My work takes a different approach and holds them as interconnected. Systems have social as well as ecological elements. Thus, they're referred to in my work as social ecological systems. The systems can be observed at various levels, each with unique trophic structures specific to the observed level. These systems exist within the larger global system and also contain smaller nested systems. The observed systems we see are thus characterized by their existing trophic structures as well as by the functions that those structures play in the supra and the nested systems. The popularity of this type of approach has ebbed and flowed through intellectual history. After a hiatus in the middle of the last century, it reemerged in ecology with the introduction of resilience theory in the 1970s. Under resilience theory, the character or the state of a system depends on the values of all system components at a given time and the relationship that those values produce. Under this theory, resilience is defined as the system's ability to absorb change while maintaining its essential character and functioning. Sufficient change in the values of components alter the trophic structures and relationships, producing change in the state of a system. And this is called a regime shift. In my dissertation, I discuss how changes in the ecological components of the system can result in the social portion shifting from a cooperative to a conflictive regime. The argument goes that we derive ecosystem services from the natural world. These are the goods and the services that nature provides which sustain human life and social life. Two mechanisms affect ecosystem service delivery. These are consumption pressure, the local level of consumption of ecosystem services, and productive capacity, the rate, type, and quality of ecosystem service delivery. Changes in the biotic and the abiotic components of a system affect levels of service delivery. These changes ripple through the supra and the nested systems and force societies to readjust to new forms of ecosystem service delivery. This adjustment requires the renegotiation of existing relationships and the negotiation of new relationships. And this negotiation creates space for social change. Conflict is one potential state that a regime can shift to. So thinking back to my research question, the framework I lay out in my dissertation suggests that regime shifts should occur in areas that are undergoing environmental change, in areas where ecosystem services are sensitive to change, and in areas where the human relationship to the natural world is changing. After discussing the pathways that lead to regime shift, I conduct empirical work to both describe which changes and which factors affect conflict likelihood, and to identify which areas of the Earth are most prone to conflict. Now, the framework cannot explicitly answer why conflict and not some other system state results from relationship negotiation. That's fundamentally a question of people, and as such requires specific theories of social change to answer it. As such, my research is preliminary and descriptive. It identifies the correlations between ecology and conflict and builds a foundation for future causal exploration. Traditional empirical work at the global scale operates with the state as the unit of analysis, both out of convenience, since states collect and warehouse relevant data, and also out of necessity, as conflict occurs inside and among states. I diverge from this approach and take a spatially explicit approach to studying conflict as it occurs in precise geographic locations. I disaggregate conflict from a state level to a local level phenomenon. This disaggregated approach involves 4 steps. First, identifying the locations that experience conflict. Next, constructing units of analysis to capture local processes. Third, measuring local environmental and ecological conditions for those units. And finally, statistically uncovering the associations between ecology and conflict. In my study, my dependent variable is the presence of armed conflict, where conflict is defined as contested incompatibility between a state and another group, resulting in at least 25 deaths per year. I assume that ecological change affects conflict likelihood regardless of the type of conflict. To test this, however, I distinguish between conflicts over territory. These are secession or autonomy conflicts. An example of this would be the sort of conflict we see in Chechnya with rebels fighting for independence from Russia, or if the Quebecois turned to violence in an attempt to secede from Canada. The other type of conflict are governance conflicts, which involve contests over the right to rule or control of the state. The Mozambican Civil War provides a good example of this sort of conflict. So these polygons describe the perimeter of battle zones for conflicts each year. They're generated by Uppsala University and they're publicly available. In looking at these conflict zones, it's evident that conflict is not spread evenly across states, but rather it exists in portions of states and across regions. After identifying the locations of conflict, I construct my units of analysis. To do this, I overlay a grid of 100 by 100 kilometer cells on the terrestrial surface of the Earth and code each cell for whether it experienced conflict in every year between 1991 and 2004. For the cells that span international borders, I divide them into their constituent countries. My study thus consists of a grid of 18,382 grid cells with roughly 257,000 observations across the 14-year period. I next set about constructing ecological profiles for each cell. The global scope and the environmental focus of my research greatly limit the availability of data. My approach requires uniform, time series, spatial data. These are costly and they're difficult to produce, and they're difficult to standardize. So hypothesis testing in my dissertation is limited necessarily to those hypotheses for which I can collect and test data. Innovations in remote sensing have made it easier to generate global environmental data, and as such I was able to collect enough high-quality data to generate and test 7 hypotheses. First, I posit that population density is positively correlated with armed conflict, the reason being that it should increase consumption pressure for ecosystem services at the local level. I measure population density within each cell based on data from Columbia University. It doesn't show up very well, but you can see physically the distribution of population. A related hypothesis is that human encroachment into natural areas is positively correlated with the occurrence of conflict, both by increasing local consumption pressure and by diminishing local productive capacity. This is a difficult hypothesis to test since there are no direct data sets that measure explicitly encroachment. So I overcome this challenge by developing a proxy indicator. I measured the amount of light emitted from every point on the Earth at night, as this directly shows expansion into previously dark areas. With both population and encroachment, I was able to capture them in real time at annual observations. So if you watch the slide, these are just 4 time periods for the area of China and Japan. But you can see very distinctly encroachment into the natural world as well as settlement patterns. The next hypotheses further address human modification of the environment. Hypothesis 3 states that modification of natural land cover is positively correlated with the occurrence of conflict, as it disrupts productive capacity at the local scale. Hypothesis 4 states that land cover regimes characterized by high biomass productivity are negatively correlated with armed conflict, as these represent intact ecosystems. Now, I could potentially condense these into one hypothesis, which states that intact or undisturbed land cover regimes are negatively correlated with armed conflict. I employ 4 variables to test those hypotheses. First, I measure land cover and assign each cell its dominant land cover category. Next, I measure the percentage of cropland that exists in a cell. I then measure the amount of pasture and potential browse in those local cells. And finally, I measure the dominant type of farming system in the areas. Together, these variables assess the degree and the type of human modification of the natural environment. Hypothesis 5 suggests that changes in biological productivity, either positive or negative, are associated with armed conflict. Remember that I theorized that change requires the renegotiation of relationships. So we can thus assume that both positive and negative change require relationship negotiation. I include 4 variants of one variable to test this. That variable is normalized difference vegetative indexing. This is a variable that measures the amount of green light emitted from the Earth. The variations in this variable distinguish between climate-induced and physically induced changes in biomass productivity. Hypotheses 6 and 7 explore the physical and climatic conditions that correlate with armed conflict. I expect conflict to negatively correlate with conditions that promote biological productivity, as these areas are more likely to provide reliable delivery of ecosystem services. So I include measures of aridity, of the soil's ability to retain water, a measure of climatic zone based on temperature, and a measure of how climatic conditions constrain agricultural productivity. Finally, I control for political and economic factors and develop measures to control for autocorrelation. Autocorrelation describes the way that a phenomenon relates to itself across time and space. For the purposes here, conflict or autocorrelates in cells temporally such that conflict in year t depends on the state of conflict in year t minus 1, and conflict in year t plus 1 depends on the state of conflict in year t. Spatially, conflict in a cell is more likely if adjacent cells are simultaneously experiencing conflict. So I measure conflict in t minus 1. I also measure the proportion of neighbors that are in conflict. And then I also measure the proportion of neighbors in conflict at t minus 1. Having developed ecological profiles for each cell, I employ logistic regression to identify which variables most significantly correspond to the occurrence of conflict. The formula for the estimation technique produces a probability of conflict for each cell based on the values of the independent variables. I estimate full models to test all the variables simultaneously, and then nested models to test each hypothesis. Again, I assume that conflict type shouldn't matter, and I run models on 3 dependent variables to test that. I run a model on the combined conflict, then one for territorial, and one for governance conflicts. Finally, since grid cells vary in size, I run models with restricted cell samples to test whether different size cells are biasing results. Pardon. The results of my models were surprising. Rather than ecological change affecting conflict regardless of type, the most prominent finding in my research is that each type of conflict is uniquely associated with the ecological profiles, and that these profiles are almost entirely opposite. Previous work on greed, grievance, and opportunity mechanisms demonstrate the same pattern for conflict types. Those works suggest that when studying the causes of conflict, each type should be dealt with separately. My research confirms this, and the correlations I uncovered demonstrate the coarseness of my hypotheses. The hypotheses aren't designed to explain why different sorts of change produce different sorts of conflict. Rather, their original function is to describe where and under what conditions conflict occurs. As such, there's sufficient evidence to at least conditionally accept each hypothesis. The models for the combined dependent variable demonstrate that conflict generally occurs in low-income, undemocratic countries. Inside those countries, conflict occurs in cells that experience increasing light or encroachment and increasing population growth, and also in warmer climatic zones. For the combined dependent variable, these are the only ecological variables that significantly associate with conflict. However, the strongest associations I found were in the autocorrelation controls. The correlations for those controls hold across different specifications of the dependent variable, across nested and full models, and across models with restricted cell samples. According to these controls, conflict is most likely for a cell when there was conflict in the previous year, and when its neighbors are simultaneously experiencing conflict. Conflict is still very likely, but slightly less so when those first 2 conditions are met, but also when neighbors experience conflict in the previous year. Now, the slight reduction in propensity likely accounts for conflict termination in the sample. The results show that when locations and regions shift into conflict, they tend to remain in conflict. The ecological profiles for each of the dichotomized dependent variables are markedly different and almost nearly opposite. In the combined dependent variable models, the opposing impact of these 2 types of conflict wash out the effects of nearly all ecological variables. However, when they're separated, it becomes apparent that ecology does in fact matter in determining conflict location. And here I've put up the different variables that are correlated with conflict. There are several implications of these findings. First, autonomy and secession claims are associated with decreasing productivity in converted lands, increasing population density but not increasing light, and strong undemocratic states in the low to mid-income range. This suggests that marginalized groups are increasingly unable to meet their needs in the face of ecological change. Development and infrastructure are not expanding, either intentionally or incidentally, for these groups, and thus not compensating for diminished productivity. The situation likely produces dissatisfaction for marginalized groups with their position inside the state, leading them to seek autonomy or independence. Conflict over government structure or the right to rule, in contrast, are associated with increasing biomass productivity, productivity in previously unconverted lands, increasing encroachment, which also signals increasing infrastructure and increasing development. And this happens in weak, transitioning, and low-income states. This potentially suggests that inside cells that experience government conflicts, ecosystems are changing. Increased encroachment means that ecosystems might no longer be able to carry the same volume of traditional livelihoods, or meet the needs of increased population. And because of the small economy and the weak state, the current government might not be able to mitigate lost livelihoods. It also suggests that expectations might be increasing for some groups based on infrastructure expansion as well as increased biologic productivity. Local changes could thus provide the opportunity for, or popular support of, a challenge to the government through traditional greed and grievance mechanisms. So after identifying the ecological correlates of conflict, I set about identifying the locations of the Earth most prone to conflict based on those profiles. I estimated predicted probabilities for each type of conflict for each cell for each year, and then generate mean in-sample probabilities. Now, these mean probabilities demonstrate only the average likelihood for cells across the 14-year period, and not the trend of the cell. Thus, the locations depicted in this map are not necessarily expected to experience conflict in the future, but rather demonstrate various propensities for conflict. So this map shows the mean propensity for the combined armed conflict variable. And this map shows the mean predicted probabilities for territorial conflicts. From this map, it seems that autonomy and secession conflicts are less common than the other type of conflict. And this map shows the mean propensity for governance conflicts. What's most interesting about my approach, I think, is the emergence of considerable subnational variability in conflict risk. This provides a real sense of the locations most prone to conflict, independent of state boundaries. So, what conclusions can be drawn from this? Well, if you accept the boundaries of the conflict data, it appears that local conditions do in fact affect where conflict occurs in the world. If you accept the theoretical underpinnings of my work, then ecological change affects how humans derive ecosystem services, and this change affects how social groups exist and coexist in the natural world. There's a great deal of utility in this approach. It offers a richer understanding of local dynamics that underlie conflict processes. This richer understanding could simultaneously inform conflict prevention as well as community, land use, or other social planning. Also, identifying conflict propensity has utility, particularly for planners, businesses, NGOs, by better offering insight into the risk associated with working in specific areas. By incorporating this approach into planning, those organizations could generate a greater return on their investment. It's particularly salient for biodiversity conservation, for development, and for humanitarian assistance programs. There are, however, some limitations to my work. The theoretical design cannot account for different types of conflict. I describe where and under what conditions conflict occurs, but not why, and not why specific types of conflict occur. The empirical design cannot account for onset, duration, or conflict termination. Thus, early warning becomes challenging under this. Next, I only model terrestrial variables, not marine and not freshwater dynamics. Those systems are very important for communities, but due to the lack of data, I can't incorporate them at the global scope. I also don't have local data on political, economic, and development variables. I incorporate coarse measures of state-level dynamics as controls, but I can't go further at this scope. Finally, I model time coarsely for most variables. I generalize trends over time, but not necessarily annual observations for each covariate. This limits my ability to forecast since I don't have annually sensitive metrics. So looking forward then, in future work, I would ideally refine my geographic focus. In this, I've been able to demonstrate coarse generalized trends at the global level. However, operating at a finer scale would allow access to better data, allow exploration of why certain conflicts occur under certain conditions. I'd also like to develop a better spatial data set. Improvements in the conflict data would include more precise conflict range, more precise measures of local conflict intensity, and also identify the modes of violence at specific locations. Finally, I would like to explore different model estimation techniques. Ideally, I'd employ models that would specifically allow forecasting, models that specifically explore onset and duration, and models that better explain geographic contagion. Thank you.
Thank Joshua, wow, and precisely, he's a precise man, and as you can tell from the content of the dissertation, and he was very precise about sticking to the time that we discussed. So perfect. Well, I want to thank you so much for this great presentation, and as tradition would have it, we usually invite our outside committee member to ask the first questions.
I wasn't aware of that. I'll have to write down. You first and foremost, you mentioned the series of hypotheses, and then in your results more generalized to the specific things such as the productivity and encroachment as being key. Just from a point-by-point perspective, do you feel like going down the 7 hypotheses that there are any that you did not feel like you were able to either accept or reject it, given your data, or was it pretty easy to say accept, reject?
The correlations for each of the covariates were very, very direct and very, very telling. Significance popped up right away, or didn't pop up at all. However, thinking about each hypothesis, not one variable tests a specific hypothesis. Rather, several variables contribute to one hypothesis. The hypothesis I feel weakest is this, hypothesis 4. What I really intended this to get at was whether intact ecosystems are correlated with conflict or non-conflict. And I measured it, with measures of biomass productivity, with land cover conversion via cropland, or lack of conversion via pasture land, pasture and browse specifically. But it doesn't get at what I was really trying to uncover. Which is why in the presentation I suggested combining these 2 hypotheses into one that models intact ecosystems.
I presume I'll have, if I just leave it, I'll come back to another question later. We can
Absolutely.
share the table. Sure.
Absolutely. Solid, you want to take the next?
Well, Josh, first, thanks for this fantastic work. It's been a pleasure to read, and I've learned a lot, and I'm excited to learn more, which is always a sign of a great project, because you have tapped into something, and it's one of these projects where I can brag to others, describe it, and get a lot of excitement. So that's always a nice thing. Just on the mere scale of it, just to share a little anecdote about Josh, when he was out at Point of View and it snowed, he cleared the driveway all the way to the street. And if you've ever been out there, that's an amazing thing. And this is that kind of dissertation as well. It's a sort of brute force dissertation, which is fantastic. So that being said, I've already written to you extensively some ideas that I have about it, but I wanted to highlight a couple things that are tensions here and that will be useful in moving the project forward, because I think that your title is right, that is correlates. We might call them associations with conflict. And it's important to highlight that, because there's a way to use this kind of work in a way that I think would be useful, and one which could be potentially not, and I just want to comment on why that is. So if you read the dissertation, and I encourage you to think about that and spend a little time looking through it, because it's quite fascinating. The theoretical framework is one in which we'll say you take an ecological view, and I point out the way in which you use the words human versus people, and that was an interesting tension in the work, and we've talked about it a little bit, and I think that's a meaningful distinction, because when you use the word human, there's a biological sense that the humans are, like other life forms, somehow getting into states of conflict, and I think the ecological theory supports that human point of view. And there's an important distinction between that and people, because when we talk about people getting into conflict, we tend to focus more on that inner nest that you put at the beginning of the talk, the notion that there are social factors which are driving a lot of this. And I'm not sure which, after having read it a couple times, I'm not sure which one of those views is right. That is this more of a dissertation about human conflict or about people in conflict? And it's a tension that I note in the work, and I think that isn't really resolved here. And I know that your theoretical frame sides on the human, and yet many of the findings might point to the people. So that's something I just want to mention. This is part of, if it's in a general sense, as I read it, I realized that this was part of a larger tradition a social explanation we call strain theory, and Talcott Parsons was associated with this directly. And there's something nice in coming back to it, the notion that when human beings are under various sources of strain, then conflict, deviance and conflict results. Now, that tradition was largely, let's say, people moved beyond that tradition in sociology and in many other disciplines as well, but that might have been premature, and I think that's something I'd like to think more about. I'd like you to think more about it, maybe not necessarily here. I won't dwell much more on the theory, but to bring up just a couple of interesting things that also occurred to me. There's a tension in the hypotheses between levels and changes, and I think that a lot of the way you speak about things is in terms of change. The aridity measure in particular suggested to me that levels, general conditions might matter, and this brings up an interesting point. Are there larger profiles? I mean, you've thrown in the profiles piecemeal. You know, that is, you have an independent variable, let me throw that thing in, and what have you. Is there some way of thinking about ecological systems, generating a typology that brings these things together in a meaningful way that it might allow you to get some purchase on how ecological systems are related to conflict in various ways? So you might think about bundling these variables, somehow creating types. That might be fascinating to do. I thought about it a little bit myself, and I haven't decided what would be a fair way to do it. I mean, I can imagine statistical ways of doing it, but I don't know what the right way to do. It'd be interesting to think about that. And then that might help you to think also about, are there places that are just likely to drive people into conflict? I mean, for example, Afghanistan, which was meant to have another Tennessee Valley Authority program there, and which just didn't work for various reasons. And so that in Tennessee, is the difference between Tennessee and Helmand that the ecological conditions are just radically different, or is it that Tennessee is in the United States? You know, and this is at the intersection of various empires in conflict. So these are kinds of interesting things that I think I think you want to know the answer to, and maybe if somehow we got into a typological exercise, we could do a little bit better with that. I'll say something about the dependent variable in a minute too. So there's an idea of a distinction. So you have two different dependent variables. Let me just say this. I could imagine the models putting in distinct lags between, and I think you have, were you in armed conflict last period? I think is the way it's specified. Right. One could imagine specifying those things distinctly. Since the dynamics are so distinct, obviously, between governance and territorial conflicts, one could imagine putting in separate lags for each of those might produce interesting results. I don't know what would happen to be kind of interesting. Also, there's a notion of multiple lags. You know, sometimes you might put in T-2, and I don't know if that matters, but that's a very minor point. A little bit more major point has to do with an issue of the multi-level nature of the data. We've talked about this as well. It seems to me that the data are naturally multi-level in the sense that you have smaller units nested in larger units, a different kind of nesting. And especially with respect to the socio-political data, it might be interesting to throw those things, rather than smoothing them across the space, that's explicitly multi-level model. That's something to think about doing, and I wonder if that might allow you to tell different kinds of stories about the findings if you did that explicitly. I would encourage you to think about that. There's more to be said. This causal logic. Well, that's an important point. Let me get to that in a minute. This issue of I wrote in my notes about the project. I wonder if there's any such thing as armed conflict at all. You remember that and on page 135 in the old draft. This is where I encountered it. And it seems to me that your findings are so startling, and that is that governance and territorial conflicts are really two different animals almost entirely, not just on the ecological variables, but also on the socio-political variables. And that just, to me, was stunning. You mentioned that the greed and grievance literature has some of that too. I don't know if that's a standard finding. I'd like to know what your feelings are about that. But it's really just an absolutely stunning finding for me, which moves in the direction of the people versus the human explanations. Because the hypotheses all promote a certain human evaluation, but the fact that they're so distinct suggests to me that, and that those are entirely socially constructed, suggests to me that in fact we might have something which is more socio-political than ecological, perhaps in some cases. Now this gets to my last point, which is that the deal of causal logic. Now you know there are a number of places throughout the dissertation where you say this is the correlates, and I can't explain why, just where, and so on. And that's nice, but it's also a standard technique we've developed given experimental science, and it can be a bit of a cop-out. That is, we actually care about why, and that's why we got into it, and that's what we care about in the end. And so you'll want to think a little bit more about that. And the main challenge that I am worried about in this respect is given the radical nature of the distinct ecological and political profiles that lead to the two kinds of conflict, could we imagine that in fact the exact opposite thing is going on? That is, that various kinds of conflicts lead to various kinds of degradation, or are associated with various kinds of relationships or parts of strategies toward the natural environment. So it's the endogeneity question, you know, like the chicken and the egg question. So it's just something that you protected yourself against. It doesn't damage the dissertation. But in terms of your intellectual interests, it's at the heart of what you care about, which is the chicken and which is the egg, or can I allow both of these things to be involved in some kind of dynamic process? And that's ultimately, I think, where you're going to want to bring your thinking. So with those being my major comments, I just want to commend you on a fantastic project that's got me thinking a lot about things that I had really not thought about.
Thank you.
Well, this is a problem, Steve, because you go after Solon, and Solon like, pretty much covered most of the points that that I wanted to make. But let me echo Solon's point about this really being a terrific dissertation that got me thinking about a lot of different issues. And as I was rereading it before this defense, I kept thinking, wow, you know, you have a research agenda for the next few decades here, just the questions that emerge from this dissertation. So one of the issues, or two sort of related issues that I wanted to raise, and they're very much connected to and building on what Solon has said. Because what struck me in this study is, you know, and in some ways when you were putting the maps on the slides, and it really brought that home again to me, is I kept thinking back to Clinton's campaign, you know, and sort of expanding it a little bit. It's the economy and political regime stupid. You know, because what strikes me here is, and you bring in, for example, the level of economic development, right, as a variable, and political regime type as a variable. But to me, they kind of get underplayed a little bit. And what is striking, especially when you look at the map of light, right, the places that are most lit up are precisely the areas where there's the least armed conflict globally, right? And so I wanted to perhaps push you a little bit more in that direction. To what extent it is people, not humans, really, sort of the point that Solon was making, to what extent it is the way people organize themselves politically and economically that really affects the way that those ecological features of the affect conflict. And so that's one question. The other one, it relates again to these very stark differences between territorial and governance conflicts, and you speculate about possible reasons why that may be. But I'd like you to push you a little further on those issues, because I could make an opposite argument why territorial or governance conflict. I mean, in terms of the sort of the causal linkages that lead people to react in a particular way, right? Why would a marginalized group try to secede as opposed to try to overthrow a regime or a government, right? That to me, it's not necessarily obvious that one or other choice would be made. That there, what else could be shaping those choices that groups made about whether to overthrow or secede? Because it strikes me as you know, that there might be quite a bit more going on there. So I wanted to throw that out to have you speculate a little more, or think through how you might want to approach that question down the line in the next phase of this project.
Yeah, I'll jump back into a couple other things now. Sorry for not having a sense of the appropriate magnitude for my questions. One area we've talked about is in your introduction is your kind of bringing in non-human examples, and certainly there are a lot of examples of conflict between species and within other species for territory, for hierarchical establishments, and in whether it's in lions or wolves or even in elephant prides. And it seems to me that one thing that kind of coming full circle around, some of your conclusions jive with some of the ecological literature. In population density, we often talk about R versus K selected species, or when you get organisms really tightly packed into a more or less steady state environment, they tend to invest a lot in themselves and not so much in batting down the next person. Whereas in kind of a frontier mentality, everybody's kind of stretching out and taking over a field, if in a weedy sense. And that transition from an early stage succession to a late stage succession is a lot like this moment you're looking at where there's a high derivative or high degree of change per unit of time in your underlying substrate. And I'm not sure whether at the degree to which you want to be bringing that at the tail end, or whether it's just worthwhile noting that the concepts of succession seem to relate to this from an ecological perspective. So that kind of captured the scarcity piece. In terms of the light as a surrogate for encroachment, it seems like it's also a surrogate for marginalization of populations, literally moving out to more marginal lands for, like we might see in Brazil, where they start working their settlements up the hill, and then a landslide comes, as has happened in recent weeks. And I'm not quite sure how that might be teased apart, that from the actual substrate or ecological, the physical and climatological changes that you refer to. But it seems to me that absent that, marginalization might be referring to itself as opposed to be related to the context. I.e., we're on marginalized land, therefore getting ticked off and cause conflict, regardless of what that marginalized land might be, whether it's low productivity or highly variable, in a floodplain, for example. And so that brought me to my third consideration, which was, you mentioned not having enough freshwater and marine data to really look at a watershed or a coastal scale. What would, from your perspective, and from this thinking from this ecological sources or factors related to conflict correlates, what sort of data, what would be your ideal data set to be able to bring in the freshwater and the marine in a meaningful way to this analysis?
Certainly water quality, dealing with freshwater. Whether it's white sulfur pollution from landmines, which the conflict pollutes the environment, or salinization of water, saltwater encroachment. Water quality would be really telling, I think, for local dynamics. You'd want to incorporate also health variables, because is the water just getting worse, or is the water quality affecting local health or local livelihoods? On the marine side, I mean, there's so much that we don't know about marine systems. One idea might be to, if you could, generate global CPUE data, catch per unit effort data, and look at changes in coastal fisheries, see how they're affecting local livelihoods. And then when you correlate that with changes in land productivity, I think what you'll see is just decreasing caloric consumption across the board. There would be several issues of dealing with lags. Does decrease in land productivity increase fishing and then decrease fishery productivity, or is it the reverse? Do they happen simultaneously? It's very complex, and it's probably not an issue that I would approach at a global scale, rather at a very local scale. One reason that I would do that deals with resources just generally. As we know, resources aren't distributed evenly across the globe. Let me pull up one slide. So the decision to include resources or not to include resources, it's a bit arbitrary which resources you include, because which matter. At the global scale, I don't see a good argument to include resources generally. If we look at known diamond reserves cross-referenced with known conflict, at least in my study period, it seems that diamonds, except in parts of Africa, maybe India, maybe Colombia, but I doubt it. It seems that diamonds don't really, at the global scale, affect. Now, at a local level, certainly, I think the case can be strongly made that resources do. The same with petroleum. These are all the onshore known petroleum reserves. At a global scale, does it make sense to include it as a covariate? Maybe not. When we think about marine systems, does it make sense to include catch per unit effort at the global scale? I don't think so. Unless you want to include national consumption of fish or imports versus exports. But And finally, offshore oil, even less of the case.
Yeah, your last comment actually is very akin to something I'm exploring in my research right now, which is really locations where there's a net export of fisheries, yet you have protein, energy, malnutrition going on onshore in the same communities. I know you lived in a region that at least there were locations where that might apply in isolated factors, but I haven't yet thought about or researched overlaying that or bringing in the catch per unit effort. So I think that's very interesting. And this public health as a kind of connection between the human and the people, the human needs and the people interactions, I think could be another interesting layer to bring in the future, where it's very ecologically derived health issues like waterborne diseases like you were mentioning, or protein and energy deficient malnutrition issues. So as my colleagues have said, you really have the seed for something that could turn into so many different interesting research directions. It's really neat, so I can compliment you on that.
And then the point about the human versus the people. One reason I stuck with human at this scope was precisely this. Do I think that the same conditions affect conflict likelihood in Algeria as Brazil, for example? I don't know that the same variables play the same role. So at the global scale, I think about humans and human behavior. At the local scale, I think we can start to get into people. And I think we have to get into people at the local scale. Or at least not this global scale, because it's very coarse.
Yeah, I mean, I think at some point that would be worth bringing up, simply because, you know, when you look at where those conflicts do occur, like those territorial and governance conflicts, these tend to be states, or because that's, you end up looking at states just because that's where policy data is located. But these tend to be states that don't have good political institutions for managing social conflicts. That seems to, that ecology matters much more in terms of shaping conflict dynamics when you don't have these social mechanisms and institutions for resolving conflicts that inevitably arise. That once you have these in place, ecology seems to matter a great deal less, and to really tease that out much more precisely, I think would be a really worthwhile exercise.
Well, particularly when you consider the economics of these countries that experience conflict, because in almost all of the countries that experience current conflict, we see very low levels of economic development, and the implication is that people are living directly off the land. Large proportions of the population directly depend on the environment for sustenance, as well as for the modes and means of economic productivity, whether it's natural resources, raw materials. Everything comes from the environment. Everything that sustains people comes from the environment, and so that's, you know, it's one reason that I think conflict occurs in these places, and one reason I think ecology matters.
I wanted to ask a question about what you think the major contribution of the work is. Is it is this thing about different these divergent patterns of correlation between the kinds of conflicts? Is that a really important thing, or you feel that's already been established? What do you think? What is the big finding that you think everyone ought to know about here?
The big finding certainly isn't the types of conflict. I think that's pretty well documented, at least increasingly well documented. There are two things that I think are important about this work. First is the subnational variability that we see. Rather than conflict just being the state, or a state phenomenon, why does conflict occur in Reston versus Fairfax? Why does conflict occur in this province versus that province? So far in most conflict studies, there's no real, at least quantitative way of accounting for that. So I think I demonstrate significant methodological advancement in that I can demonstrate, you know, a very high degree of subnational variability.
Are the rivals doing that right now?
No, not at the global scale. There are some people who have tried to do it, but rather than using absolute location, conflict as it occurs, at a Cartesian coordinate. They do it at relative location, so distance to the state capital, distance to resource base, distance to shipping lane. But everything is relative, not absolute in this way. And the reason that I think that I have confidence in my methodological advancement is when you look at my predicted probabilities, if you look at the bottom of my correctly classified cells, I have a pretty remarkable, there's a pretty remarkable amount of power in the models. 99% cells accurately predicted for the combined model, 98 for territorial, 98 for governance. I did something right. A lot of it has to do with the spatial lags and the temporal lags. But my pseudo R-squareds in the statistical model, my model fit, range from at least 0.58 in the territorial, which is not that great, but it's still, for science, it's pretty substantial, to about 97 for the governance. So I think there's something to be said for the models that I've generated. I think I got at your question. Maybe I didn't.
Do you want to remind us of the N you were using for this?
Yeah, the N was 18,382. So when you factor out cells with missing data, it goes down to about 18,157 something, but it drops by about 5%.
That brings me to another question. How big a problem did missing data play in this, and how did you handle the missing data?
Missing data, more than really frustrating my models, just limited my variable selection. Mm-hmm. So I had originally included public health, disease rates. I had included caloric budgets, but I only had them for about half the world, and for almost all developed countries, but developing countries, not really. I had good data on hunger levels, but only in developing countries. They just omitted the developed world.
So you dropped the variables. The strategy was you dropped the variables. You didn't impute any values.
No.
And it didn't cause. And you didn't have to throw out many cases.
No, I threw out about 15% of the observations.
15%.
Yeah, so I dropped from 257,000 observations to 218,000 observations. But given the number of observations, it still, it still allowed me to explore what I was trying to do.
We can safely say you probably had more points, data points than most ICAR species combined. Or just
there was a lot of data. I think total of 100 or 110 gigs of data. So.
You mentioned this as one of your contributions. Did you have another one you wanted to elaborate on?
Yeah, the other was specifically related to conflict studies. Very few conflict studies actually look at the natural world from this perspective. I don't know of one actually that looks at it from this perspective. People do look at resources, but not at the global scale or not at this disaggregated approach. So I think, if anything, I've tried to build a bridge between the natural world and the social world that people from my discipline can readily get behind or readily understand. The first 10 or so pages of the dissertation is really just a naturalist essay on why we should be concerned about the environment as people interested in preventing conflict.
So you had climate, I think, as your 6th or 7th hypothesis in there. We're starting to get a point where we're downscaling to units about the same size as your predictive units at 100 by 100 kilometers. Is this a direction you see you might be going in to kind of say how how do our climate change models overlay with my conflict models to forewarn hotspots?
The climate research that's going on has some real utility for me because suddenly, at least of course, local level data on temperature and precipitation are available. I couldn't incorporate them in this study. I wanted to, but annual, interannual observations are becoming available at the local level. So I think climate is one of the biggest things that constrains or affects biological productivity. And as that's dramatically changing, I think we need to be aware of it, and I think we need to model it, and I think we need to understand how that's going to affect social groups.
Great, thank you.
Should we not hog? Since we've had an opportunity to ask a lot of questions, I wanted to open it up to our other audience members. If you have questions for Joshua, please feel free to.
There's some more refined calculation technology in the pipeline that might help you do this more easily, and then perhaps hand this over to conflict zone planners and interveners in a way that they can get it more easily and use it.
Well, there have been two real advances. One is in remote sensing. You know, all my data, most of my data at least, come from satellite imagery. Most, not all. But it's made it really cheap and really easier, at least, to compile these data. And most of the remotely sensed images are starting to become publicly available. So those advances have made it easier for people who are interested in it to find the data and get the data and use the data. The other innovation has been GIS technology, and that's geographic information systems. These are computing tools that allow you to collect and manipulate spatial data. And they're sort of user-friendly. There's a learning curve, but with a couple months of investment, you can get to the point where you can manipulate these spatial data very easily and add a lot of value to just the raw satellite images. Dandy?
Two quick questions. Actually, one ties into what Jim just asked. Based on the number that you just called out in terms of the data, so I was wondering exactly what type of software program you use to crunch the data. And just by the mere number alone gives me goosebumps. Secondly, based on the reviews from the committee, it seems like a really terrific work. And I must say, it seems as if it holds lessons for each and every one of us in this field. So I'm definitely looking forward to reading it at some point. And I'm sure Collier, who has been looking at some elements of this, will probably be very proud of the work that he's done. In that vein, if you ever meet with him over, say, for lunch or something, what would you say to him?
If I were to meet with Paul Collier for lunch,
I'm sure you will. So
the first thing I would say, and it's maybe a bit brash, is that in some ways he got it wrong, because he really does. I mean, he tries with modeling techniques to get around it, but essentially he says that it's greed and it's grievance, and it's the scarcity of natural resources that cause conflict. I think it's not that simple. I think certainly greed and grievance do affect conflict propensity or groups' ability or desire to fight, but I don't think the environment is related to conflict in such a coarse way. I think it's more cumulative. I think that's one. I think resources are one aspect, but I also do think that productivity, that water availability, that water quality, they cumulatively impact social groups and social systems, and that produces stress for those groups. And it produces perhaps such incremental stress that groups might not even understand that they're experiencing this stress until it's reached a threshold, which we probably can't measure, but until it's reached a threshold where they can no longer tolerate it. And then you experience these really violent conflicts, where if they had been able to identify those underlying changes and those incremental changes early on, they might have been able to better adapt or behave differently with each other to address the situation earlier. And I tell him I like his work.
And then he can pay for it.
Yeah.
Well, thank you so much. Now comes the fun part where the committee leaves you for a few minutes. And I'm sure we do the torture ourselves to discuss and make a decision and come back.
Great. Thank you. Okay. So then I'll put everything together. And so then